Hi everyone, today we are going to talk about graphing quadratics from standard form, but first please pause the video for this quick warm-up. Okay, go ahead and check your work. Here we do have a vertex at +7, +9, and then our A value and the reflection give us a vertical growth pattern of -2, -6, -10, or again, you can always make a t-chart and plug in values to the left and right of your vertex. Here, please note that I did ask for inequality notation. I know that usually I use interval, but every once in a while I might throw that in for practice. So our domain is all real numbers, and our range is y is less than or equal to 9. Okay, so today we're going to focus on two main characteristics of our quadratic functions. One is symmetry, which we have talked about in the last lesson. We're going to be defining our axis of symmetry today. So we're actually going to be writing the equation for it. It's always going to be a vertical line, and it's always going to go through the x value of our vertex. So our axis of symmetry is always going to be x equals h, whatever that x value of the vertex is. The other thing we're going to be defining today are the maximum or minimum values. So all parabolas will have a maximum minimum value, and they will always, always, always occur at the vertex. Now, if I'm asking for a maximum or minimum value, I am asking for a y value. So I will be looking for the y value of the vertex. But of course, to know the y value of the vertex, we may need to first find the x value of the vertex. So you can see when your a value is positive, we are going to have an upward facing graph. So I like to think of it as a smiley face because a is positive. But if we have a smiley face, that means that we will have a minimum. Now, if your a value is negative, if you have a negative out front, we have a downward facing graph like this. So it looks like a sad face because it's negative. But when you have this downward facing parabola, you will always have a maximum. So today we're going to be graphing our equations from a different form. So last class we did vertex form. This is what we call standard form. So y equals ax squared plus bx plus c. So to graph from here, we have to start by finding the x value of the vertex. So you will need to memorize this little formula to help you. The x value of the vertex will always be -b divided by 2 times a. So b is always the coefficient of x, and a is always the coefficient of x squared. C is what we call a constant, which is a term without a variable, or it's just a value. From this form, it's really easy for us to see the y-intercept, so that's really nice. Our y-intercept is always just going to be that c value. Remember, we find a y-intercept by setting x equal to 0, so both of these terms disappear, leaving us with c. And we will still use, or you still can use, the vertical growth pattern, a times 1, 3, 5, 7, 9, etc., to graph additional points on your parabola. Or alternatively, again, you can always create a table of value and plug in points from there. But I like to use that vertical growth pattern once I know the vertex. All right, let's give one of these a try together. We're going to graph, we're going to define the axis of symmetry, find the maximum and minimum value, and do the domain and range back to interval notation. So the first thing I need to do is find the vertex. So I'm going to start by using my little formula, x equals -b over 2a. So I'm going to say x equals negative. I see that my b value is -6, so I'm going to substitute that with parentheses, divided by 2 times our a value, which is 3. So I see that x is +6 over 6, so x is 1. Now, once you know the x value of the vertex, you do need to find the y value. So I'm simply going to substitute that x value into my function. Notice that when I'm doing this, whenever I substitute, I do it with parentheses. So I really would like to see everyone doing that. Make sure we follow order of operations here. 1 squared is 1, and then I multiply it by 3, so it's 3. We don't do 3 times 1 then square it. That would give us 9, which is a very different outcome. So we have to square this first and then multiply it by 3. -6 plus 1, so f of 1 is -2. So our vertex is 1, negative 2. And then for my vertical growth pattern, my A value is 1, so I'll do, my A value is 3, so I'll do 3 times 1, 3, 5, and I get 3, 9, 15. I could continue that pattern more if I wanted to, or again, I could just plug in values to my function rather than using my vertical growth pattern. So here's my vertex. So from that vertex, I'm going to go up 3 over 1, and then I'll go up 9 over 1, and that's plenty for a nice accurate graph. And then I just connect my dots. Okay, now let's look for our maximum or minimum value. So here, since we have that upward facing parabola because of that positive A value, I do see that my graph hits a low point and then turns around, which would be a minimum. So for this, we're always just going to name the Y value. Anything to do with height, we want the Y value. So our minimum value is Y equals negative 2. You'll see it's always the Y value of your vertex. For our axis of symmetry, remember that's the vertical line over which our graph is symmetrical. So it's a vertical line that will always go through the X value of the vertex. So the equation of that line is X equals 1. And then we know our domain should always be all real numbers. And here our range is negative 2, our low point, to infinity. All right, let's try another one together. So here we have negative 2x squared plus 8x, and that's it. So here our C value is 0, and that is completely fine. It's also fine to be missing an x term. That just means your B value is 0. You do have to have an A value because you need to have an x squared term to be a quadratic function. Okay, let's start by finding that x value of our vertex. Again, I always recommend writing out our little formula, negative b over 2a. So we have negative 8 over 2 times negative 2. So that's negative 8 over negative 4, which is positive 2. And then I'm going to plug that into our function to find the y value. So again, be careful that you're following the order of operations here. 2 squared is 4. 4 times negative 2 is negative 8. And then here plus 16, so f of 2 is 8. So that means our vertex is 2, 8. And for our vertical growth pattern, I'm going to multiply 1, 3, 5 by that a value, negative 2. So negative 2, negative 6, negative 10. So I'm going to go down 2, down 6, and down 10. Since it fits on our graph, why not? And so here's what our parabola looks like. Okay, so here in this case, since we have a downward facing parabola, here I have a high point, so I have a maximum. And that maximum value is always going to be the y value of our vertex, which is y equals 8. Our axis of symmetry is this vertical line, which always goes through the x value of your vertex, so x equals 2. And our domain is all real numbers. And our low value for our range is negative infinity. Our high value is 8. And there you have it. All right, let's try one last example together. So here I have this function 1/2 x squared minus 4x minus 2. So it's okay that we have a fraction as our a value. We're still going to use the same formula. Negative b over 2a. So negative, here our b value is also negative, over 2 times our a value, which is 1/2. So that gives us positive 4 over 1. So our x value is just positive 4. Let's plug that in to our function to find the y value. So here, 4 squared is 16. 16 times 1/2 is 8. And then here we have minus 16 minus 2 So we can see here that f of 4 is negative 10. All right, so our vertex is 4, negative 10. And then for our vertical growth pattern, remember sometimes for this I like to extend my pattern a little bit. So 1, 3, 5, 7. I could do more if I wanted. So 1 half, 3 halves, 5 halves, 7 halves. So I can go up 1 half over 1, up 3 halves over 1, up 5 halves over 1, up 7 halves over 1. So it gives us some nice coordinates to work with. And then I'm just going to reflect a couple of those over my x-axis, or over my axis of symmetry like this. I guess I could reflect all of them, why not? And here we have plenty of points to make this an accurate graph. Okay, here again we have an upward facing graph. So we have a low point, which is a minimum. And that minimum is going to be y equals negative 10. Our axis of symmetry, that vertical line that goes through our vertex, will be the equation x equals 4. Our domain is all real numbers, and our range is negative 10 to infinity. Okay, here's the last example for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So our vertex should be at 2, 8, and then I followed this vertical growth pattern to gain some additional points. Our maximum value is y equals 8. Our axis of symmetry is the equation x equals 2, and here's our domain and range. All right, that is all for today's video. Thank you so much for watching.